Hi, I'm Tommy.
I'm Miranda.
I'm Allie.
And I'm Tony, and we're Group 2.
We're a Georgia Tech team from Dr. Garcia's ME 2110 Section C, competing in the 2016 Final Design Project.
Today, we are going to present to you an update on our problem understanding by discussing the project planning tools we have created in order to ensure our success in this battle.
In order to compete for the 2016 ME 2110 Final Design Competition, two specific problems must be addressed. Completing tasks to score as many points as possible, and doing so with consistency and accuracy, all while abiding to the rules. In order to thoroughly define the problems and requirements that must be addressed for the competition, the hazard quality was developed. Amongst the most important customer needs identified are to remove the black net from the home base, autonomous operation, reliability, and efficiency. The engineering requirements that best satisfy the customer needs are range of motion, efficient code, robot execution, and stability.
Next up is the function tree. The purpose of this planning tool is to outline and organize an assortment of wide-ranging requirements by dividing functions of the machine into simple subsets. The three broadest sets include autonomous operation, completion of tasks, and meeting size restraints. These are elaborated upon in lower levels. For example, the complete tasks category is broken down into the specific tasks which the machine must carry out. As you can see, these are even further elaborated. For instance, defeating the Black Knight involves removing our own Kong, but also keeping out others. The other two broad categories are subdivided similarly.
Here we see the specification sheet, or the spec sheet for short. The goal of the spec sheet is to provide details about the performance requirements that the machine must satisfy. These requirements are organized into categories. Let's zoom in on a few. By looking at the operation category, we see a few important specs listed, such as the machine must operate autonomously and stop all operations completely after 40 seconds. This column identifies if the specification is a demand, D, or a wish, W. Specifications marked with a D must be satisfied. If they are not, the machine can be disqualified from the competition.
The morphological chart depicts ideas for accomplishing the bottom line tasks established by the function tree. Some initial ideas in the first column represent the obvious typical solutions most teams will consider. Moving toward the fourth column, the ideas tend to get more creative, but also more complex. The team would like to continue down this path, brainstorming more atypical ideas to test. This will hopefully lead to a working solution, as well as a strategy most teams will not expect and therefore not prepare for. This also helps the team anticipate certain tactics many other teams will try to use and prepare to combat those common threats.
The purpose of the Gantt chart is to assist in creating timelines for the major tasks of the project. Gantt charts can be as simple or as complex as necessary. Our chart lists timelines for 20 major tasks. Our chart is divided into 5 task categories. This method allows the team to visually see which portion of the project we will spend the most time on. One important observation we can make is that the tasks in the prototyping and deliverables categories have overlapping timelines. This tells the team that we must produce our deliverables as we construct and test our prototypes in order to meet all the deadlines.
The objective of the prioritization matrix is to compare key tasks involved with the final design project and associate higher number values with the most urgent tasks. For instance, the construction of task-specific designs has a value far exceeding the other entries, suggesting it is of the utmost priority. Meanwhile, assembling and testing the machine has low priority since it can only be carried out after other requirements have been met. The prioritization matrix allows the team to plan activities so that buying materials must be completed before part manufacturing can occur, thus expediting the entire creation process.
The affinity diagram groups ideas based on similarities. The 4 categories are completed tasks, improved software, improved hardware, and repeated success. The tasks circled in the first column are the subsystems that we should excel the most for scored points during the competition. For the improved software, it is crucial for all subsystems to operate autonomously with a start plug. The most important ideas under improved hardware are circled. Stability and strength for the robot to execute several tasks simultaneously without compromising the structure of the robot is crucial. In order for repeated success, consistency in its performance and its ability to absorb damage and still function properly are key.
The planning tree breaks down the steps to succeed in this competition. Understanding the tasks will be extremely important because there are several specifications and rules to be met. Familiarization with available resources, developing concepts, and prototyping should work in a cycle together for the bulk of this project. The team plans to experiment often and devise applications of findings towards design ideas and prototypes. Brainstorming several ideas and alternatives will provide options and inspirations, which will ultimately translate into a superior final design. The spatial dominance of prototyping on the tree conveys its importance in truly understanding different ideas through hands-on experimentation. Compiling a final design is pivotal, but heavily relies on the time and effort spent in previous phases. The actual final task will be continuous testing and improvement.
Today we introduce our planning tools for this project.
These tools have allowed us to realize the most challenging and important aspects of this assignment,
thus allowing us to understand the problem well enough to prioritize our objectives properly and develop time management strategies to ensure their completion.
Thank you for your attention, and we'll see you on the battlefield.